Yeah, just thought I'd have a little look at this. I was digging through a box of old valves and found this one. This is an ECF80. These were used in VHF television tuners, and it's a double valve really. It's got a Pentode part and a Triode part to it. The interesting thing was they picked this out because this white top here indicates the valve has got air in it. And the valve is good. It has this silvered top, which is the getter. So this indicates the condition of the vacuum and also maintains the vacuum. When the vacuum fails and it can't work anymore, it tends to turn white. So I just thought it might be worth having a little look inside, see how these are constructed. So with a little persuasion you can break the glass up and disassemble it. So this is the what they call the getter ring, which is what is inductively fired to leave that coating on the surface when the valve is being manufactured. These are the actual Triode and Pentode assemblies inside. You can see there's a little gap between here. So these can independently be run actually, except the heaters, the two heaters at the bottom are in parallel, so they will run together. Focus in a little bit, what you're actually looking at are really the anodes on the outside of this. These are the actual anodes here and here, and this is the mica support, both top and bottom here. This is the cathode here with the heater just visible, and on this side it'd be, heater's just poking up through here. Can take off the basically they spot weld all the bits together, so this is a bit of shielding here with the attached to a getter ring, so that then exposes the top of the mica plate with the grid and cathodes are visible now, and I can further dismantle this by releasing the mica plate with, once these little tabs are picked up again, that should release the mica plate. Is just about free, there it is, and that lets you see inside the anodes. This valve has had the air in it for quite a long time. The grids should be nice and shiny, but the corrosion is quite bad in it, so there's been moisture in here. You can see a bit of rust forming, and this is a screen here that is between the anodes. Now take the anode away from the Triode side, which I've now released. So lifting that off, you can see the grid and the cathode inside. So that's the spirally wired bit is the grid, and this tube in the centre is the cathode. You can see the heaters here, that's the heaters going inside the cathode, so indirectly heated cathode. This kind of whitish area is the emissive oxides added to the cathode to improve the emission. I should be able to take the grid off now, I think. It's the actual grid there removed, and the cathode now is visible on its own. Okay, that's the cathode exposing the heaters on their own. And that's the filament heater for that cathode. That's the two heaters with the connections. You can see they're parallel, so when you can't power one heater up by the other, without the other. And if we look at the Pentode side, this is the screen which is actually connected to the cathodes of this particular part of the valve, and that's the anode around the Pentode. And again, you can see there's a number of grids here. So this time we have our control grid, our screen grid, and our suppression grids around the cathode here in the centre. Okay, this is the complete valve dismantled and the components placed here. So this is the Triode parts to this side and Pentode parts to this side here, and this part's the screening. These are the parts of the screening components between the two. We have the anode for the Triode grid and cathode side, and on the Pentode side we have cathode, control grid, screen grid, suppression grid, and anode here. These are the two mica supports, top and bottom, and the getter here, and the heaters for both elements here.